What's up, everyone? In this lesson, we'll be covering the between two sets algorithm question on Hackerrank. This one's rated as easy, and we'll cover two different methods. First method will have a bunch of lines of code. Second method, first method is we'll have a bunch of lines of code just to show all the logic, make sure everyone can understand what we're doing. And then second method is just really a consolidated version of that. We'll really appreciate one of the functions that's available within Python. So first things first, as usual, let's try to understand the question that we're working with. Essentially, we'll be provided two arrays, and we need to find numbers that are evenly divisible by the numbers in the first array, and then whatever numbers pass those criteria, we want to see if these numbers in the second array are evenly divisible by those. Numbers being anything from 1 to 100. So yeah, let's get to work. Okay, so first method, like I said, is going to be a little bit longer. Let's write out what we're testing with. So what do we want to do? First, we want to find what numbers we'll be working with. So a number that is evenly divisible by these, and these numbers are evenly divisible by, we know we'll have to fall in a range that is from this number to anything less than this number. We know that like 15 won't work. That's quite obvious, but for the sake of the algorithm we're going to write, we might as well just test up to this number. So let's identify those numbers through our code. So we're going to loop, of course. We're going to want to loop through those numbers. So let's call beginning, which will be the beginning of the loop. Beginning will be equal to max of A. And then we'll also need the end of the loop, and the end will be equal to min of B. Okay, great. So what do we need to do? Like I said, we'll need to loop through those numbers. So let's write that out. For n in range beginning to end. And we're actually going to have to write this a little bit differently. It will have to be end plus 1, because we want to include that last number. Nope, my parentheses didn't go. Okay, great. So there is our loop. Okay, so how would we keep track of numbers that are numbers within this range, so ends in this range, that are evenly divisible by the numbers in A? So what we could do is we can store them, and we'll write might. So what I mean by might is that these numbers may be divisible by both, and only if they are divisible by both, we'll actually do something with that number. Okay, so let's write our next loop. For num in A. So now that we are looping through our range of numbers between our two arrays, we're going to want to loop through our first array. And what are we going to want to do? If n modulo num equals 0, that's good. That's giving us that's meeting the condition. But that's only meeting the condition for num. It needs to meet the condition for both nums. So we will might dot append. What do we need to append? We need to append n. And let's go ahead and print this. to see what we're working with. We're going to print n. Or sorry, I meant to print a might. Okay, cool. So in these scenarios, we are taking n and we are dividing by the number in our array A. So what would n be, what would the first n be? The first n would be beginning, which we set equal to 4. So the first number we're working with is 4. Is 4 evenly divisible by 2? Yes. So we're going to append that to a might. Is 4 evenly divisible by 4? Yes. So we append that to a might. Next number we're checking is 6. Or sorry, not the next number we're checking, but the next number that meets any condition is 6. 6 is evenly divisible by 2. That's why we see it here. But because it's not divisible by 4, it's never added to our a might again. So the maximum length of this array winds up being 1. And we're not printing the array if it doesn't meet any other conditions, but essentially any other array that that would be processed would have the length of 0. So basically that means if the length of the array is equal to 2, or it's equal to the length of A, then that means that that number meets the condition that 2 and 4 can be evenly divided. Okay, so what can we do? We want to write that out. So that would be if length of A might equals, oh, I'm within parentheses, apologies, equals length of A, we are going to, let's put that in a new array that we'll then use to test with this second set of numbers. So let's call that A works, meaning that when we loop through A, these numbers satisfy the condition. And we'll set it equal to an empty array. Okay. If the length of A might is equal to the length of A, we will A.works dot append A might position 0. Really, you could do A might position 0 or position 1, but we just know that either of those are going to be the same, and there's always going to be a 0, so you might as well just append that one. Okay, awesome. So that means we should have, at the end of this first for loop, that means we should have, let's print A works. Should be an array of a couple numbers, looks like 4, 8, 12, and 16. And that's exactly what we get right there. So we're going to delete this print on line 13. We'll leave A works for now, because we'll be working with A works in the next loop. Okay, so what do we want to do now? We want to see if the numbers in this loop are all divisible by the numbers, or sorry, the numbers in this loop. We want to see if the numbers in array B are divisible by all the numbers in our new array, A works. Okay, so how can we write this? For n in A works. Okay, we can do this very similarly. We can write b might and make that an empty array. And for, oh, I'm within that array. That is not on purpose. Apologies, wish I knew how to type better. Okay, let's scroll back up. Okay, for, and then we'll of course have to write a loop for num in b. And remember, this is going to be a flip-flop of what we wrote here. It's going to be if num modulo n equals 0, because it's the one is the factor of the other, and then that flip-flops for the second condition. If num modulo n equals 0, we will b might dot append. We'll append again n. Okay, so we've appended n, and then back to what we were saying earlier, we had some conditions like the number 6 arose. So 6 sufficed for 2 because 6 is divisible by 2, but it was not divisible by 4. So the length of that array wound up being 1. So again, we only want to store the number if it's divisible by all the numbers. So if b might, if the length of b might equals the length of b, that means that all the numbers do divide, and we would want to keep track of those. So this is the array. Let's make an array of the numbers that satisfy both conditions. And the question says that they are called numbers between. So any numbers that satisfy both of these conditions are called numbers between. So let's go ahead and call a new variable, a new array, numbers between, and set it to an empty array. Okay, so then what do? We numbers between dot append b might, and it's going to be the same number that appears multiple times in the array, so same thing, we can select the first one. And then we've got an array. So what can we do? We can check it out. We can print number between. And see what numbers satisfy both conditions. Oh, of course, we've got a syntactical error somewhere. Sorry, my computer's running super slow. Looks like we're missing a 0 here. Hopefully that fixes everything. Not quite. Num modulo. Oh, you know what? There's not supposed to be a parentheses there. And then, of course, number between is not defined because I wrote numbers between. All right. There we go. There's our answer. Sorry about that. Okay, so hopefully this makes sense. It's really quite simple once you understand the steps. Do it a couple times. Keep printing. Print n. Print your nums. Print your arrays. If you're getting caught up, just keep on doing that. I'm sure you'll figure it out. Just keep trying. But there is a really powerful Python tool that can make this question, all of these lines of code, we could turn it into like 4 lines of code, including the return. So let's go ahead and do that. Okay, so the function is called all. So we're going to want to loop through that same range that we worked with last time. So let's go ahead and do that again. Beginning, be great if I could, let's just call it begin, because I love to make typos when I write begin. So what's the beginning? The beginning is the max of A, and the end is the min of B. And that's just because of how the math works. Hopefully you're understanding that part. And don't just take it for granted. If you aren't understanding it, again, just work on it, understand it, and then move forward. So we've got our beginning and our end. Let's go ahead and write our loop. For, what should we call them? For integers in range of begin to end, and we're going to want to do the same thing we did last time. We want to include the end number, so we've got to do end plus 1. Looks like I'm missing a parentheses, and we'll go colon. Okay, so this is where the real money is. Okay, so the function is called all. And this will really start making sense once we have the code written. Basically, though, it's saying if all of the numbers in A meet a criteria, then that meets our condition. And then we can make the conditional statement, we can add end if it also meets a certain criteria for all the numbers in this array, then great, we can actually do something with that. So let's do it. If all what could we do? We can write num modulo what is x? We can do x. If num modulo x for x in A. Okay, so let's break this down. What is x in A? Oh, sorry, this would have to be integers. So if the integer divided by x, and x is every number in A, so x would be 2, and then x would be 4. I think in the last version we called it num, so let's go ahead and call it num again. So integers are this range. We'll start at 4 and go all the way up to 16. So integer 4 would be the first integer here, and num would be the first number in our array here. So if the integer modulo num, and what do we want? We want it to be equal to 0 for that range of numbers. And so, okay, that is the entire first condition met right there. And all, and then it's going to flip-flop num modulo integer, because this is the second condition, and we know the number being divided is flip-flopped versus the first one, equals 0 for, what did we use here? We did num in A, so it would be num in B. Okay, a long line of code, but one long line of code that replaces a ton of other code. And so I hope you're following that these two statements are the conditions. And if it satisfies both of those conditions, we're going to want to do something. And what could we do? For the last one, we actually really didn't finish it. We printed the array that held all the correct numbers at the end. But what this question is asking for is just the number of numbers that would appear in that array. So the last one would have had 3. So we're working with all the same numbers, and that means we're going to have the same answer. So let's store it as a value called answer. And every time we get a number that meets this criteria and meets this criteria, we'll just add 1 to the number variable answer. Answer plus equals 1. And then down here, we'll print answer. Looks like we've got a syntactical error here. Oh, integers. There it is. Okay, just a little syntactical error or typo, really just a typo. Let's go ahead and run it. We get 3. And if you wanted to set up an array, you could set up an empty array and append the numbers that meet these conditions to the array. But really what we're looking for in this problem is the number of those numbers. So that's why we're printing answer. So let's go ahead and copy all this. Head over to Hackerrank, pop it in, get it formatted. And of course, we want to return answer, not print it. Okay, we've got that. Hopefully that takes care of everything. All right, that looks good. Get some space here. Too close to making me anxious. Okay, it satisfies the 2 sample conditions. Now let's test everything. These 2 took a while before too. Oh, there we go. Okay, great. So that is it. I hope you enjoyed. I hope you can really appreciate the power of the all function. Keep that in mind. Test it out. I'm sure you'll be using it again at other points in your coding journey. If you have any questions, feel free to pop them in the comments below. If you enjoyed this, please hit the like button and hit subscribe. I'll be doing these very frequently. Thanks for watching.